And now, before the coffee break, we continue with the discussions of the hands-on groups. Is there Martin in the room? Martin can organize that.
Hey, so as we know, we did have quite a number of hands-on activities throughout these past 3 days, starting on Tuesday afternoon with scoping and tier 1 analyses on these 3 different cases that were presented. And I'm now actually curious what we're going to see about that one. We do have presentations from sunscreens, I heard. We also have presentations for the other case, the silver-based textiles. On Wednesday we had basically then tier level 2 assessments with CUSA lab and also this pink workflow where a CUSA toolbox was requested by a kind of in silico workflow, also in combination with synthesizability and some functional aspects. And in parallel LCA determinations, and then finally on the Thursday yesterday we did work on social LCA integration and on integrating all that into MCDA by the 2 different approaches that we offered via the sunrise, sunshine kind of tradition of projects. So these approaches versus the Integrano Asina case provided by Alex and Lisa on the one hand and Massimo and Mattia on the other hand. So I'm actually waiting for the volunteers presenting this work now. Who wants to start? At best you bring your USB stick with hopefully some slides on that, or you just kind of do it out of scratch as we have seen from Georgios. I guess this can also be done. Give some reflections if you have, that would be great. Yes, please do so. I will do my best to do this as quickly as possible to get this on this presentation screen. And if you want, you can already start inaugurating.
Oh, I will wait for
this one.
And there is a Wednesday PM.
Okay, I guess we are ready for getting it on the screen.
Okay, so ladies and gentlemen, I would like to present the results or to show you our work on the topic sunscreen from Group 2, also known as Grandma and the Youngsters. So if you cannot connect names to faces, here is our picture. So first at the beginning, of course, we were submitted documentations and we were going to check our scope. So here you can see that our scope was to determine the most suitable alternative to replace oxybenzone in sunscreen formulations in accordance with the safe and sustainable by design approach. And we were considering 3 options: titanium dioxide, zinc oxide, and carrot extract. Because as you can see, if you save your whole year for summer holiday, you just want to arrive there, splash the sunscreen on and enjoy your holiday without being burned or without thinking of consequences that these sunscreens can have on your skin, on your body, on your health. According to the documentation that we have gotten, we have identified routes of exposure for humans as well as for an environment. For humans, we have identified that you can be exposed, of course, via dermal exposure, then inhalation in case that the sunscreens are, for example, in a form of spray, or, of course, oral ingestions, as, of course, we put sunscreens also on our faces. When it comes to environment, this can be exposed via manufacturing facilities, waste disposal, accidental spills, and transportation activities, and as well, of course, human utilization, for example, water, sea, aquatic environment. Yes, so after we identified these routes, we said bravo, and we continued in our work. First of all, of course, we had to do work on our strategy, what we are going to do. And since at the beginning we have received 13 formulations that we were supposed to choose from, which is, of course, which can be, of course, hard. We went to through the functionality to assessment of safety and hazard, using also MCDA and some tools, and we evaluated our results. So when it comes to functionality, according to what we got, we were, as I said, provided these 13 different formulations, and we were provided with the reference values for the different physicochemical properties, where it was, for example, stability, also, of course, how good these compounds protect us from UVA and UVB light, microbiological parameters, and so on. And from all of these 13 formulations, so we were going just step by step, characterization by characterizations, and we came to a conclusion that formulation number 11 was in scope with all the reference values. Then we have chosen, we were doing this blindly, so we didn't know which compounds are in or which formulation exactly at the beginning. Then we have chosen formulation number 1, although it does not, the reference value for UVA is not in scope, it's 70, so it's a little bit lower, but it has a good protection against the UVB, which we know is more dangerous. So we have decided that this is our second alteration that we are going to work with, and then it was formulation number 6. So we have checked which formulations these were, and we found out that the first one that we have chosen was actually 5% carrot extract. Number 1, so the second variation was 10% titanium dioxide, and number 6 was 18% zinc. So we have actually chose all of the variations, all of 3 different substances that we were that we were going to check. So again, we said, what? Bravo, yes, we said bravo. And we went on. Since ECA database was down, we have received safety data sheets, and according to this, we started to fill in this chart where we were working with all three substitutes, so titanium dioxide, zinc oxide, and carrot extract, and here is the benchmark or reference product, which is oxybenzone, and we were filling in the categories according what we found in the SDSs. So you can see we were checking carcinogenicity, mutagenicity, reprotox, and so on, since skin sensitization. So there were quite a lot of categories that are, of course, very important, and we were classifying them in different categories from not classified or saying no if the data were missing. So it was miss, category 1 according to CLP. So this means that the compound has negative or the most negative impact or the hardest negative impact. And then of course you can see category 2, 3, 4 or not applicable. So we have filled this, chart, and then we said, what did we say after this? No. We actually didn't say this because we were saying, okay, what now? We were split into groups, and one of the groups went to work with predictive analysis software. So I was not involved in this part, so I will just briefly tell you what I was told. So these predictive analysis software that were used were Jackpot, which is still not, if I understand, on the market or online. Then it was used by QSAR Toolbox and Pink. My colleagues from the group, they were testing or predicting 5 different UV blocker substances, and the only downfall of this was that the databases are built for only substances, but are not suitable for nanoparticle data. So here is just, for example, a comparison of Jackpot and QSAR. So Jackpot was easy to use. It was not as comprehensive and has accesses to more models from EPI, Suite, QSAR Toolbox, and Vega Hub. And when it comes to QSAR Toolbox, there was information overload and very comprehensive. And as you can see, they were working or putting here into QSAR Toolbox. These are the information on oxybenzone. And as it is stated here, this page goes on and on and on and on. So it was like never-ending data summary. Okay, so here are again pros and cons of Ping Stage 1 report. So it consolidates information from different models, but what is very good, it visualizes discrepancies and alignment in the final results, dependent of substance. So you can see this beautiful pie chart graphs, and so it has a good visual cue to fastly screen the substances. If there is anything you would like to add, you can just scream at grandma. Okay, good. So, then we said bravo, because this was good, and then another group, or not another group, but the next day with Alex, we were working on the Sunshine software or tool or app, where we were assessing the MCDA tier 1 for all 3 our substances that we were checking. So I would just, for shortage of time, I would just like to show you that according to what we have presented to the software, our alternative carrot extract showed increased functionality towards the benchmark oxybenzone, but also the decreased safety compared to oxybenzone. Then we did the same thing with zinc oxide, so you can see the same trend. Functionality went up, but safety went down. And again, in tier 1, titanium dioxide nanoparticles, again, functionality compared to reference substance was higher, but according to safety data, it was lower. So this is just the general comparison that was done through all of the 3 substances compared to the benchmark. And you can see that the carrot extract is slightly higher than zinc and titanium.
Excuse me, higher in what?
This is just the functionality, so it comes from what I understood, it comes from functionality and safety, so I'm not very familiar yet with the whole program, but it said like it put all the data together and it made this comparison between the compounds. If I'm wrong, you can please just correct me. Is it fine? Is it correct?
Yeah, you have some questions that are related to the positive performance of safety, I think, and functionality, and then you sum up this positive contribution in order to understand, in comparison with the benchmark, how is the situation. Here you can also add that the light blue is related to the uncertainty, because maybe you have many questions that you replied as I don't know. So in general, it is higher. There is also uncertainty in the light blue part.
Yeah, because also, of course, we didn't put all the data. We were missing a lot of data due to, of course, this is just the training. So, but thank you very much. Thank you.
Maybe one more question that I had earlier to this slide. You were saying carrot extract was less safe than the oxybenzone. Maybe you can give us a little bit more detail why.
It might be due to the data of aquatic exposure. We can go back. No. Okay, so we had some data missing. I do not know now which exactly. What were we putting into that? We were just putting this data that we have received from the...
Okay, skin sensitization looks like, right?
Yep. Functionality.
So it can
and
lead
so
to
there
allergy?
are, yeah, so it is, yeah, skin sensitization was one, and then it was toxic organ, what was it? Targeted organ toxicity, no, aspiration hazard, sorry. I can't see there properly. It was also aspiration hazard.
Which you learned from the
Category 1.
Which you learned from the MSDS, or what?
SDS. We have received the SDS, yeah.
Okay, safety data sheets.
Yeah, we were just working what we had, and actually I was going to talk about this at the end, but yeah, I will explain why, okay. Thank you for the questions and explanation. And here is a general tier 1 comparison between the 3 substitutes, which shows that the functionality had high benefit, marked with a green star, but a low safety benefits with the red star. And you can see that there were some of the environmental, social, and economic data missing, or we haven't had time to deal with these. This is tier 2 results that were submitted only for the carrot extract. So hazard analysis, it has passed all the how would I say it? Anybody? Threshold, yeah, thank you. Thresholds, yes, thank you, I was looking for the word. And when it comes to environmental sustainability, it failed at ozone formation, marine eutrophication, land use, and water consumption. So this means that it has big negative impact on the environment. This is again just an overview where you can see that production safety is very low, as well as environmental sustainability. This is what I was going to say, that even from the beginning we had a couple of questions that if we were working on a real case that we would like to ask the stakeholders. So first, I would say observations. So the alternatives, or to sum up, alternatives present higher functionality. Alternatives present no safety benefits and raise some significant concerns. And overall, it seems to be no advantage in using alternatives from our preliminary studies. However, of course, the analysis is incomplete. There were a lot of missing data or information, so we would need to do more research. There were discrepancies between safety data sheets and methodology of plant extract preparation, for example, because in the data that we have received, it was said that the whole carrot is being picked up and used to extract, for extractions, whilst in the SDS it was stated that it's oil from the seeds. But of course, this was also because the ECHA database was down, so we were working with what we had. But anyways, these were our concerns. Then we, of course, don't know nanomaterials sizes, are there any coatings that are going to be used, etc. And of course, when we went also through the list of the ingredients or in the formulations, there were also some hazardous material that we were thinking if we would innovate, for example, if this can be in a way modified, for example, ingredient list for fragrances that we could use, because if you are a little bit familiar with the cosmetics industries, you know that the fragrance or perfume can actually be composed of dozens or even hundreds of other components that don't have to be stated, which can of course raise another risk to the consumers. So, and this is it, and I would like to thank you for your attention for Group 2, and we would really like to thank Alberto and Amaya for really nice guidance and help, and also Alex for help with the Sunshine software or app or platform. And Ben for taking pictures. For what? For what? Yes, because you were different groups. So thank you. Any other who we should thank? We would like to thank sponsors, and we are very glad that we were participating here. No, I just needed to know, to thank. And we were really glad that we can be here, and we enjoyed it utterly. Thank you again.
Hello everyone, I hope you had a nice coffee break. We also had an interesting coffee break. So now we will present what we did in our case study about antibacterial coatings for textile, mainly biomedical textiles. So first of all, why do we have this case study? So often silver nanoparticles are used to coat textiles because they have an antibacterial activity. But there is one problem, that it leaches into the environment by washing. So we found a redesigned product, and this redesigned product coats the silver nanoparticles so that they remain attached to the textile. And this is a very quick example of how the process works. The first day, we did a scoping analysis where we discussed the 4 questions: why, what, how, and who. And you can see our results from the discussion here. So we checked in which life cycle stage, which dimension is in which life cycle stage, for which dimension there is a problem. And we prioritized these different challenges, and we found that there is a problem with the manufacturing of the coating because it uses heat and it takes kind of a long time. And then that it is washing out the silver nanoparticles which leach into the environment. So we focused on this one. And the what is that we wanted to increase the durability of this antibacterial coating. And this we do by encapsulating the silver nanoparticles, and relevant for our process are the workers, the users, the innovators, and the society. So after that, we looked at the process and we defined our system boundaries. So we have the different unit processes of the production process, and finally the use phase, the final product and the use phase. And we consider this in our life cycle assessment, which we did in an Excel sheet, so I will move to the Excel sheet. So we started with the step 0, which is the production of silver nitrate, which we then use to produce silver nitrate solution. So we added all the inputs that we need, also electricity, what we needed from previous steps, like here, the silver nitrate that we produced before, and it gives us the impacts in every environmental impact category, and calculates what it is then for our final product. This we did for more steps, so we have also the HEC solution, which is the coating that we use to make the nanoparticle more resistant to leaching. And we tried with different weights, with different concentrations, to see which one has the lowest impact categories, which we then mixed with sodium hydroxide to get to the final hydrogel solution. Also, hydrogel solution, we have different concentrations to identify which one has the best combination of environmental impact and antimicrobial bacterial activity. Finally, there is a spray coating, and with this data, we then calculated that we did an SSBD assessment. So I will change again. Okay, so the next step was to do a life cycle assessment by considering also the functional unit. So in the beginning, it was just this 30 milliliters of hydrogel solution produced, but it depends on the yield, depending on the concentration of these different components of the nanoparticle. It depends on how well it stays or how well it is deposited and how much time it can be washed before it loses its function. And this was considered in another Excel. So we have it, which one is it? This one. No, it's not this one, sorry. So here we have different formulations of our new product, and these are also called key decision factors. We have 6 of those, and based on the milliliters of the weight of HEC solution, we needed different amounts of sodium hydroxide, and we got different antibacterial activities, one for E. coli and one for S. aureus. So we decided we want to see how both of these bacteria are fought. So we added a new column, which is the minimum antibacterial activity. So of these two activities, we chose which one is the minimum, and this should be maximized. So this was one of our key performance indexes, but I will talk about it afterwards. And these are all the environmental impacts that were calculated in the Excel sheet before. And we have also cost, how the cost changes for the formulations, how the cytotoxicity changes, and we also have social impact points. They are also divided in the different impact categories, but we looked only at the total impact, social impact. With that, we got to our results. By considering the functionality, which I discussed before, the ecotoxicity, climate change, cytotoxicity, we also considered cost and social LCA, because we have 4 stakeholders in our group. We have the business people that are very interested in costs. We have environmentalists, which are interested in how climate change and ecotoxicity is impacted. Then we have toxicologists, which need to know what happens to humans, so cytotoxicity was included. And then we have the innovators, which are mostly interested that the functionality and the performance is as high as possible, in this case, the antibacterial activity. And with these key decision factors, the 6 formulations, which are here shown with the blue dots with an NM, we cover a big range of the design options. As you can see, on one axis you have the molar ratio of the sodium hydroxide, which is needed, and on the other side the ratio of the two components of the nanoparticle. And so by running the script, we get these performance spaces, and each of these 6 key performance indicators are shown on one axis. The most relevant for us is this one because it shows how the antimicrobial bacterial activity compares to the cost and to the ecotoxicity. And we are mostly interested in the antibacterial activity, so we decided to go with these options that are here. Oh man.
You have to do the pointed.
How do I show it? Oh wait. With this one. Can you see this one?
Yes.
Okay. So we have here the options that have the highest antibacterial activity, so the best performance. So we try to see, okay, we have these few points, which one of these is the best? So we compared it also to the climate change, which is shown here, and to the cytotoxicity. And based on discussions about trade-offs, we found that number 47 for us is the most interesting, which is hidden in this picture, but it is here. So the higher the HEC, the hydroxyethyl cellulose, the better the option for most of the indicators. So what are take-home messages? In tier 1, we need to make many assumptions. There is not so much data, and we need experimental data to discuss the assessment or validate the assessment. And then in tier 2, we need multidisciplinary discussions because different stakeholders have different interests and priorities. Then we need to discuss the trade-offs that come up by these performance spaces. And finally, the option that we chose as the best option, we need to validate. I want to thank all the people that helped us in this case study, Benjamin Punz and Irini with the scoping analysis. Then we have Mattia Costamagna with the LCA support. We have Massimo Perucca, which supported us with the case study in general and the MCDA, and he ran also our calculations. Finally, we want to also thank all the speakers of this training school. They gave very nice insights. The organizers of the training school for this nice week, and all the participants for these good vibes. Thank you. Oi.
Thanks a lot, Fiorella and team, for this nice overview on the case. Questions? Comments? One question from my side. This 47, whatever compound, the one that you identified with the most of the HEC coding, this had, what I was seeing at least, a high ecotoxicity. So maybe you can maybe explain on the previous slide, right? It was high up in this corner, so it means also on the x-axis it's having this high freshwater ecotoxicity, right? Or is this then an inverse?
The best option from the performance perspective is also the most impacting one, but we decided that if the function is not given, then it can also not be sustainable. So why use it if there is no function?
Okay.
So do you think it was like a general agreement? So you had discussions like, for example, some of you thinking that maybe ecotoxicity or even like human health should have like a higher weight, you know, compared to functionality. So did you have like these moments like to discuss or these debates?
Yes, so in the beginning we discussed to consider as much key performance indicators as possible to get all these performance spaces, but then when we have these many trade-offs, we prioritized which performance indicator is most relevant, and that's how we came up with the options.
It's interesting that the business people did agree because it's also the most costly one, isn't it?
Yeah, we were more environmentalists than business people.
You know, I think also like, for example, maybe an opinion. So how was like the experience for you guys to do this analysis, to perform these assessments, and also like to use these tools? Positive one, was complicated to use maybe some of the tools? How was the experience during this week?
Does anyone want to answer? Huh? Okay, so I will start. I think the experience was very interesting because we have different backgrounds and we have different interests or also kind of values. And so we were very quick with getting to one conclusion by some discussions, which when you are alone, you might be biased and follow one route which is interesting to you, but by these discussions and this short time, you are more efficient and consider many perspectives and dimensions. And I think this is very interesting and also crucial for an SSBD assessment.
And I don't know, I also want to add that we really appreciated having Ben and Mattia and Massimo, because it was really difficult to get to know all the assumptions made for the LCA and for how the modeling of the MCDA worked. So it's very sad that Massimo is not here anymore, but I hope he's proud of us.
Everything is taped and will be provided.
Thank you, okay.
Yes, please.
Okay.
Oh, there is
Yes.
one question.
Just last question. Fiorella, very good statement. I mean, if we have no functionality, what are we looking for? In any case, one question about that. Once that you arrived to that multi-decision discussion, when I guess everyone had a different or similar idea, was any one of you against this statement?
Against the cost?
No, against the idea that first of all, it's functionality, and then we can think about environment.
I think everyone agreed. No, except the business people. They were like, we have to also. No,
Thank you.
I know that's what people want to hear. No, we did all agree for the sake of functionality that cost sometimes has to go to second place.
Thanks.
And one last thing, I really want to thank our team for coming together.
Oh, yes.
Yes, it was a very nice experience, really, as Jelena said, working with very different disciplines and even language, we managed. Yeah, so thank you.
Yeah, thank
Congrats,
you.
really greatly done. A big applause to the team.
That was so funny.
And also, I guess I transmit a big thanks for the, from the trainers to the attendees for this cooperation and taking this now really seriously. I hope this has provided you with some insights across a fence of your own expertise into kind of the methodologies of other experts, either in LCA or at the safety side or at functionality side or at cost evaluations and all these kind of criteria.